So finally, we need to ask, what's going to happen when the graph of a rational expression has common factors in the numerator and denominator? If we simplify, right, we need to simplify a rational expression to its simplest form before we do anything else, well, after we find the domain. But in this case, let's write f of x in factored form to help us out. So here's f of x, right? If I factor it out, I get f of x is equal to, in the numerator, I get x minus 4 times x plus 3 as the equivalent expression. And in the denominator, I get x minus 4 times x plus 2 as the equivalent expression. Right now, the domain of this function and the domain of this expression won't change, is the set of all values of x such that x does not equal -2 and +4. There are two values that must be excluded from the domain. But when we reduce this expression and rewrite it, f of x can be written as the equation x plus 3 over x plus 2. But we have to provide, because we've canceled that factor out, for the fact that x cannot equal 4. So we actually write that on the side and make that our stated domain. But this function right here, x plus 3 over x plus 2, will be the one that we actually graph. So how will that look? Well, in this case, we've determined the domain. Our vertical asymptote will occur in one and only one place, and that is at the line x equals -2. We can only use this reduced expression to get that. Our horizontal asymptote is going to occur at the line where y is equal to the leading coefficient of the numerator over the leading coefficient of the denominator, and that's 1. So we've got two asymptotes already, a vertical asymptote at x equals -2. That's our only vertical asymptote. And our horizontal asymptote at y equals 1. So next, the question might ask, well, what's going to happen at x equals 4? Well, in fact, what's going to happen is that we're going to get a hole in the graph at that location of x. How will that look? Well, we need to plot this graph as though it weren't there, and then we'll put it in at the end. So if I were to plot this graph, I note that there is no symmetry, even or odd, so I'm just going to go through it. I'm going to determine the behavior near the, check my asymptotes to determine my behavior near the asymptotes. As far as the y-intercept, we find that when x is equal to 0, y is equal to 3/2. You can check that, pause and check that out for me. Our x-intercept occurs wherever the numerator is equal to 0, and in this case the x-intercept is going to occur at -3, Again, please check that out with me right here, but we will have this x-intercept at -3. Let's get another point that's at least near the vertical asymptote. So let's try it at x equals -1. So let's get a couple of these extra points right here. At x equals -1, we're going to find that y is equal to -1 plus 3 over -1 plus 2. So that's +3. And I always get at least a second point near that vertical asymptote so I can tell what's going to happen. And let's take a look at what happens at -4. If I take -4 plus 3 over -4 plus 2, that is +1/2. So this graph is going to pass to the point 4, -4, +1/2. One more point that we need to get is right here. What happens at 4? Well, at x equals 4, we say there's going to be a hole in the graph. What happens at a hole in the graph? Well, a hole means that we can plot this point like we would normally substitute in 4 into this reduced expression. That would be 4 plus 3 over 4 plus 2, which is to say 7, 6. But at this point, what's going to happen is that we're going to get a hole in the graph. We place an open circle to represent that coordinate point that would normally be on the graph. And it's like it pops out of existence. And so this graph will come along the horizontal asymptote at y equals 1, pass through our 2 points to the left of the vertical asymptote and head down towards negative infinity. And it's going to come down from positive infinity along the vertical asymptote at x equals negative 2. Start heading down towards that horizontal asymptote, then all of a sudden pop out of existence, and then just wink back in and just head right along y equals 1. So we have this hole, and we should label it at the point 4, 7, 6. And that's the way that we'll refer to it. A hole in the graph at the point 4, 7, 6. And so this is what our graph will look like. Good luck with your assignment.